So I think I realized why people don't find rocks interesting. And I think the first reason is you don't get good rock samples in school. And the second is you're not really ever taught what the rock is saying. So I'm going to try and answer both of those. And I think you're going to realize why looking at rocks is so enjoyable. So try and hang in there with me. So the first one is let's deal with the bad samples you get. When you pick up most rocks, they actually look all the same. They have this brown coating around them, and it's difficult to make much sense of it. Even if you cut a rock, like this one here, it's not really fresh and there's still weathering. And so the rock is best broken, fresh, and then you can see the cleavage planes and how it breaks, and that helps you work out what sort of rock it is. It's a characteristic of one of the rocks. And so what you're looking for with a gabbro is you're looking for olivine, this medium light transparent crystal, and pyroxene, this black blocky crystal. And as you can see from the fresh cut here, the large crystals are really easy to see, but when you're in class, number one, you don't get good samples like this. And on top of that, you won't be allowed to break them because you can't replace them and they're not easy to get. Um, so nice samples like this, you can see it just look amazing compared to a dull brown rock. So I think that's a big issue right there. So you don't really have something to start with. The second really big issue is the story. So um, the story is difficult. I had to do some research, and part of it just sort of worked out myself. Okay, so this is the story about what it is and what it means. So number one, you'll pretty much never see a gabbro. Okay, so the reason is as magma cools, the silicon dioxide molecule, which is the building block of all rocks, it has like an infinite number of three-dimensional shapes that join together. And the larger the structure, the lighter it is, because the silicon dioxide on average is lighter than most other elements or compounds, such as the metals or even aluminium, because it's two oxygens. So it's lighter and it rises to the top. And because it rises to the top, it solidifies and becomes granite made out of quartz, feldspar, and mica, the larger silicon dioxide structures. And so it's also because they're these large silicon dioxide structures, they're very resistant to weathering. And so that's all you see. That is what continental crust is at light. It's light, it rises to the top. That's all you see. Okay, to get a gabbro, you need the elements. It's made up of olivine and biotone. Now, olivine is not interlinked with silicon dioxide. It's sort of by itself surrounded by metals. So that makes it even harder to find because it's easily weathered. So it's not in strong bonds. So it's like a double whammy. And also these heavier compositions. Um, because it's heavier, it sinks and it makes up oceanic crust. And what you're going to see is the quick cooling stuff, which is basalt. So again, you're not going to see the gabbro. And so the large crystals, which is the gabbro, which is basalt cooling slowly, is going to be underneath. So pretty much it's impossible. You'll never see gabbro, right? And so this is another big problem with the story. You need to go in and not even look at a rock, and it'd be good if you only ever looked at rocks that are in their natural setting, um, and not have a rock just put in front of you. And because the natural setting explains what it is and how it got there. And so where did I get this rock? Well, it comes from this enormous caldera. It's basically a huge volcano, that just sunk in on itself. The magma chamber collapsed. And so this huge volcano just blew up continental crust everywhere. So all over southeast Queensland, New South Wales, with over 100-kilometre radius, there is there is granite which has being melted very quick, melted and then cooled very quick rhyolite. It's all over the place. And then tuff, which is pyroclastic flow of the melted granite, and pumice, which is the melted granite. So all the granite's just been blown up, spread out everywhere. And so there's no There's none of it left. And so, so this is Mount Warning, called Wallumbin now. And so there's no continental crust left, and now there's basalt, only basalt, the heavier stuff left, and there's basalt flows everywhere as well. And so underneath would be the slow forming gabbro. Again, you're going to have no chance of seeing it. Okay, so that's the end of the story almost. But then, so the magma chamber collapses in on itself, and then there's a huge erosion event, possibly a global flood. And so that's where the gabbros get exposed. So you can see how tough it is to get access to these rocks. Okay, and then so the event of you ever finding, or if you find it, you recognize it, is very low. You have to know what you're looking for and where to go. Okay, so that is what the Gabbro is telling you. Hope you found that interesting. Hope rocks make a lot more sense now.